specific humidity also. Or in some textbooks, you'll find it as absolute humidity. And they are denoted by omega. Okay, omega. So what is humidity ratio or specific humidity? Basically, it is the ratio of the mass of vapor present in a given air sample to the mass of dry air in the same sample. Okay, so ratio of mass of water vapor in air sample or some air sample to the mass of dry air in same air sample. So we can write omega as mass of vapor to mass of air. You know that the air contains several things, like it contains nitrogen, oxygen, carbon dioxide, inert gas, then dust particles and all. But when we deal with air conditioning, we have to filter the dust particles and some other poisonous gases. So after that, what is remain, that is fixed percentage of oxygen, carbon dioxide, inert gases, nitrogen. So in that case, the proportion or the composition of dry air will remain constant and that will not vary. So you can treat air as an ideal gas, because there is a theory that at low pressure and high temperature all gases behaves ideally. So that's why I can use ideal gas equation PV is equals to mRT. But remember friends, I am writing mRT. So here R will be characteristic gas constant. Okay. It will be characteristic gas constant. I hope you all know, when we write PV is equals to nRT, there R is universal gas constant. And the value of this R bar is fixed, and its value is 8.314 kilojoule per kilomole K. Okay. So if you want to calculate R, why we need R? Because see, you need to change this value. Okay. I've told about the air part, but what about the vapor part? How you can treat vapor as an ideal gas? According to the theory and experiments what scientists have performed, they come to know that when the pressure is less than 3 atm, you can treat vapor also as an ideal gas. So you can replace this M with P of vapor into V of vapor upon R of vapor into T of vapor. And this part as this way. Hope you can see how I have written this. In previously I have told you by Dalton's law, this PV and PA will be equal because they will occupy the volume of the container. So let's try this out. And temperature TV and TA will also be same. It will be same as the volume of the temperature of the mixture present in the container. Okay. So you can write this as PV by PA into RA by RV. Now you need to calculate RA, okay? How you can calculate RA? There is one formula when you are calculating R, means characteristic gas constant. It's equals to R bar divided by molecular weight of the same gas what you have taken for analysis. Suppose we are taking vapor. We know vapor is what? H2O only. And the molecular weight of H2O is what? 18 gram per moles. Or you can write it as 18 kg per kilomole. And what is the molecular weight of air? If you take the compositions as 0.3% of carbon dioxide, then 21% of, basically it's 23% of oxygen by weight, and then 77% of nitrogen. By that way, if you take, you will get molecular weight as around 29. Approximately you can take it as 29 gram per mole, okay? Not a problem. Now substitute these values here, okay? So what will be the R for vapor? It will be R dash divided by 18. And what will be the R for air? It will be R dash by 29. Hope you all understand it. So you can see previously by Dalton's law I have already told you that the total pressure you can also write it with PT. It will be the pressure of air part plus pressure of vapor part. So instead of writing PA, you can replace this PA with PT minus PV. So replace it. And substitute these values here. Okay. You will get this as 18 by 29. If you solve this, you will get one value 0.622 PV upon P total minus PV, okay? You need to remember this expression. So I'm enclosing this value in black box. Now, this is what the derivation says. But there is one more thing. In some of the exams, they might ask you show the linear variation of omega with PV. What happens if PV is very small, very small, than PT, total pressure? In that case, then you can replace PT minus PV with PT. Okay. Then omega will be 0.622 upon P total into PV. Yes. So, since the total pressure is what? Total pressure is measured by the barometer, and it will not be going to change unless you change the number of molecules present around the surrounding, or whenever you change the number of molecules present in the surrounding or in the container, in that case the total pressure will change. But in the given situation, PT will remain constant. So I am replacing this part, okay, as constant. Name it some constant K. Then omega will be K into PV. So here now you can see that omega becomes the linear function of PV. So you can draw one graph also. It may be asked in some, I think it has been asked in some exam. This will be omega and this will be PV. Linear variation. Hope this thing is clear to you. So this is all about the humidity ratio or specific humidity. So now we will see some other properties. You need to understand these properties carefully. So you have to look into the video again and again if you find any doubt. Better to look in some songs like Despacito. You can look in these videos. Okay. Now going to some other property like okay. Let's see about the relative humidity. Okay, it's denoted by phi, and it's basically represented in percentage. Okay, percentage. In short form, it's RH. RH. So, what is relative humidity? Basically, when you take a sample, in that I told you that it's a combination of air and water vapor, means it's a mixture. Now, at any given temperature and pressure, you can hold only certain amount of water vapor. The amount of water vapor present in the air, it can be 0 or it can reach to some maximum value. And now the situation is that at a given temperature and pressure, the amount of water vapor present in the mixture can reach maximum. And when it reaches this maximum value, when the water vapor present in the mixture reaches a maximum value, in that situation, that mixture is called saturated mixture. Okay, saturated mixture. Saturated mixture means maximum quantity of water vapor that air can hold, or you can write just with moist air, no problem. Moist air, that moist air can hold at a given temperature and pressure. This is very important, okay? It should be at a given temperature and pressure. Now, as you got the meaning of saturated mixture now we can look at what is relative humidity. Basically, what is relative humidity? The relative humidity is the ratio of mass of water vapor in a given sample, in a given air sample, to the mass of water vapor, okay, when it is fully saturated for a given air sample. So now we can write phi with some mathematical form. It will be the mass of water vapor for the given air sample and some temperature to mass of same air sample at a given temperature when it is fully saturated. Since we know that PV is equals to mRT, ideal gas law equation will be valid. So you can write, replace M with P of vapor into V of vapor upon R of vapor into T of vapor. Similarly, this one you can replace with P of vapor saturated, volume saturated, upon now, since it's for the same air sample, then this and this will remain same. Since it's a vapor and the composition is not changing, so R will also remain same. And since I said that it is at some temperature, because the saturated mixture is for some temperature, okay? So this will get cancelled. So you will be left with PV upon PVS at same temperature. This is fine. The value what you will get here, it will be a fraction, okay? So you have to multiply it with 100 in order to get it in percentage. Okay? Better to enclose it. Yes. This is 5. Oh, first, otherwise, let me discuss dew point temperature, okay? Because that is also a property. First we will finish all the properties, then I will draw psychrometry chart. Dew point temperature. It's represented with TdP, okay. Mostly in degrees Celsius. So what is dew point temperature? First, let us draw TS diagram. Temperature versus entropy diagram. So here I will draw two lines, okay? Two curves. Let me draw it straight. So here you can see two lines. Basically, suppose I am writing this temperature as T, okay? This temperature as TdP. Why I have written, I will explain it now. Suppose you have a unsaturated condition or a mixture that is unsaturated, okay? If you have an unsaturated mixture, suppose somewhere here, suppose. You have a unsaturated mixture of vapor and air at this point. Suppose mark this point as A. Now, what dew point temperature says, when you cool a sample, unsaturated sample, at constant pressure, then you will reach a point where a first droplet of dew is formed. Then that temperature, or the point where first dew or droplet is formed, that temperature is known as dew point temperature. So suppose I have a sample at this point. Now I started cooling it at constant pressure, okay? This is constant pressure line. All of you know, I suppose. So you started cooling it. Cooling it means decreasing the temperature. The temperature goes down. So eventually it reaches this point. I mark this point as B, okay? Suppose I mark this point as B. So as soon as you reach this point B, a dew or a droplet is formed, droplet of water is formed. So this temperature is called dew point temperature. Okay, so this is the basic definition for dew point temperature. So this is about dew point. This is also a property of the mixture that we need to calculate or determine from the psychrometric study.